Alright guys, today I have my Sinclair ZX Spectrum Plus 48 kilobytes Speccy Plus on the workbench, and this one has an interesting keyboard defect. And you'll say, okay, keyboard defect, of course, you need to replace the membrane if you have dead keys. But actually it's a little bit more interesting than that, so I must say I don't know the Speccy that well actually. So I grew up with the Amstrad CPC, and my CPC did not have a keyboard membrane, but I know that for the more recent CPCs, and I own a few of those nowadays, you have to replace the membranes, right? And a bad membrane with broken conductive silver paint traces usually results in missing or dead keys. So key presses are no longer registered as key presses. So that's usually a sign of a bad membrane. Keys are missing. But with this Speccy, like I said, it's a bit more interesting. It's not that the key presses are not being registered, but these key presses here in this row, this corresponds to one row in the keyboard matrix, QWERT, causes the machine to reset, and only after the machine has warmed up for a bit. So initially, it's cold and you power it up, it works for a few minutes, so I can even load games from microdrive. I have an interface 1 here, interface 2, as well as the ZXHD here for the HDMI monitor output, so we can see it better here. And given that this defect is not all that common, at least when I googled for it, I couldn't find an obvious hit and explanation on how to fix that defect. I figured it might be interesting for us to try to fix this together, because clearly the defect is localized to one row in the keyboard matrix, and so it has to do something with the circuitry that is responsible for this row of keys, because the other keys don't show that defect, right? And I also already inspected the membrane. To my eyes, the membrane looks perfectly fine. Also, if there wasn't contact, right, for these keys, then it wouldn't cause a reset. So it has to be something with the decoding logic and the electronics in this machine. So let's fire it up quickly. Let me show you how it works. Hopefully, when it's still cold, right? Gotta wait a bit quickly for the ZXHD to come up. One more reset, and hopefully we can now still use the Q button here, Q plot, right? I was able to use it once, and now the second time already resets, right? So it goes that quickly that these keys, see, this one still works, and then it starts blanking out and giving bad things, right? R is also rebooting the machine, so Q works once, right? And the warmer the machine gets, basically, the worse the behavior. So now I can no longer even get this partial faulty behavior, partially correct behavior, where I see at least a little bit sometimes of the depressed key, right? Plot still works, but then after a while it resets as well. So something is wrong, and only with this row, because now let me demonstrate the other keys here, right? All of those work perfectly fine, so it's not something like RAM, ROM, EULA or anything else, because all these keys are perfectly reliable and work well. But as soon as I push down here, right, reset. So yeah, very odd behavior indeed, and so I think we have to gotta have a look at the schematics and see what's going on. Yeah, so here's the Speccy opened up, and this is the keyboard. It looks like a real keyboard, right? I mean, but in fact it's just a membrane keyboard. So under this plastic cover here, you'll just find the membrane, and you can see the foil ribbon edge cable connectors coming out here, right? And I think those are really fine. So I also removed this back cover plate and inspected the traces on the membrane. I don't think that the membrane is actually the problem. So we gotta check the electronics of the Speccy. And so what we have here is a revision or issue 3B. You can see that here, issue 3B. And thankfully the schematics are all available online. So let's start with the keyboard matrix, right? And remember that we had issues with the keys Q, W, E, R, T resetting the Speccy after it warmed up a bit. And yeah, so this is one column, right, in the matrix. And you can tell that there's also a diode involved here, D2. So keyboard D7 line goes to A10. And I think given that all the other keys are working fine, it's also safe to assume that the row logic here, the row decoding logic, is working fine. So there's probably no issue with this part of the circuitry. So my first hypothesis is this might be related to a faulty diode D2. And so if we look at the board, then we can easily identify these diodes here. Keyboard diodes, right? So what I'm going to do is just make sure that these are still good. In particular, we have D2 here, this one, and we gotta check that the forward voltage drop should be 0.6 to 0.7 volts, and in the reverse direction it should block, right? No current flow, shouldn't be conducting. At least not for the voltages that the diode test mode here of the multimeter will be supplying. So the multimeter is set into diode test mode. You can see that, is it actually? No, this is conductivity test mode. So let's put it into diode test mode. So you see the little diode symbol here. And now let's check all the diodes basically one by one, right? And see what we get. So this is the forward voltage drop for the first diode, 0.65. That's fine. Now we have D2 here as the next one. And so what do we observe there? Interestingly, this is also good, right? So forward voltage drop is good for D2. So that, the next diode, so we have 8 to test, of course, for 8 keyboard matrix columns. So far they all tested perfectly fine. But of course we have to also check the reverse direction so that it does not conduct in the reverse direction. Good. And now for D2. Alright. Well, did I see something there for a bit? No, I think actually that D2 seems to be okay. Well, there are some spurious readings sometimes, but I think this is from me touching other traces on the board. So I think D2 is actually okay. Just while we are at it, I think we already know that the other diodes will also be okay. So they all do not conduct. How about this one? Yeah, they do not conduct in the reverse direction. Okay, so yeah, so it's not that easy then. So the diodes all seem to be okay. And what else can it be, right? And so here we have issue 3B schematics from the net. We see the diodes here. We already tested them, so those are okay, right? And what else can it be? There are a few more components involved. So this is the keyboard row logic here. And I already said that I think that this is all good. Here is the ULA. And then here we have two chips which are connected to the keyboard columns. 74 Alice 157. I think those are line multiplexers or selectors. And if one of those is broken, right, then maybe that could explain it. So zooming out a bit here, so we have D2 here, right? So this is a line, the column that is giving us problems, and if we follow this, then it goes into something that's labeled IC3 here, the 74LS157. Now the weird thing is, if we look on the board, right, where actually is IC3, and I can't actually see any IC3 here, but I see of course that there is a 74LS157 here, and so my hypothesis is that this is IC3 here. And how can we verify this? So all we got to do is check if there's conductivity here between pin 11 and D2, right? So how do we find pin 11? So we simply count, right? So 8, 9, 10, 11. So this pin, if this is IC3 here, right, which is on the board labeled as IC25 actually, not 3, then it should be connected to this diode here, right? And so let's verify this hypothesis. Let me put this multimeter in conductivity test mode. Okay, and now we put one probe here, right? Pin 11, and bingo. So this is IC3, and the next thing that I'm going to try is remove that one, put a socket in and replace it, and see if that fixes the issue. Alright, that's going to be our next step. Yeah, so I got the chip removed. This one here, right? Sitting here. Looking good, I would say. Okay. Ouch, who spotted this? So this was a stupid mistake, even though I said we have to double check to make sure that the socket is put in the right orientation. I of course reversed it, right, flipped it around, so the notch is actually not where it should be. It's facing down here to the bottom and not to the up. And of course I put the 74LS157 in reverse. Nothing worked, the screen just didn't come up. I only saw like garbled black and white. And after a while this chip got very, very, very hot. So, and then I figured, of course, oh, okay, so I made a mistake there. I flipped it around, and now let's see if that at least powers up now again. Well, that seems to be looking good. So at least we get a ready prompt. Optimistic that maybe, just maybe, our repair maybe fix the issue. I don't know, we will see. Alright, I'm very excited. I don't know if this is going to work. This is the first time I'm putting it back together. And fingers crossed. So if it's the ULA, then it's already hot and warm enough, so it should show the effect right away now. Okay, so the old buttons are still working. That means at least we didn't make it worse. Should I dare pressing T? Ah, and it's still doing it. Well, I think I'm out of ideas for now. What else could that be? So, I guess it's the ULA, right? I mean, something is going on with the keyboard decoding for that line. And I'm going to try to order a replacement ULA. Okay, but let's not give up that quickly. So I have to admit that was a bit disheartening. So I really thought that replacing this 74LS157 IC3 here would have solved the issue, or you know, that diode D2 could have been responsible. but diode D2 checked out okay, and we replaced 74LS157, which is actually IC25 on the board, not IC3, but still the same issue, right? And then I removed the heatsink from the voltage regulator here. Once you do this, you will see that there is a whole bunch of more 74LS157, which I didn't see at first. So looking at the schematics, you will see that these are those guys here basically, and of course there's also still IC4, right, which we haven't replaced yet. So I went ahead and also removed IC4 and those guys. Alright, so we got that done. So we have new socketed 74LS157s here. If this failed now and the machine is still having the issue, then I can try to replace the CPU. I have a Z80 at hand. Let's put a socket in. I don't have the ULA, so if after all of that it's still not working, then I suspect it's the ULA, in which case I need to find a replacement. But yeah, let's power it up and see what it does. Yeah, seems we made it worse. That's not what I was hoping for. Okay, let's open it up again. So it's on the bench again, and yeah, my eyes are definitely not what they used to be. Upon closer inspection I found, it seems I missed one pin here, and it's a power pin, right? And we definitely would have made it worse. Okay, so the other pins I think look good. Somehow I overlooked that. Let's check it out. Alright, with a bit of anxiety, let's power it up and see if soldering in that power pin made a difference. Ah, yes, that is looking much better. Great, okay, that would have been so embarrassing. I'm making all this long video and then, you know, in the end, I made it worse. So, okay, so at least we are back to the state where we were. Now let's put the keyboard on and see if we improved there, right? So the keyboard is back together, and I'm curious to see if we made any progress after all that. And I must say, I'm a bit skeptical by now. T, okay, T is working for a bit. Alright, but then it starts doing its thing again. It warms up. And it's failing after a bit. So it seems that we still haven't fixed the problem. Q is going into reset quite quickly as the machine warms up. The behavior gets worse. Even hear some weird noises from the speaker now. No change for the other keys. So that's all. At least we didn't make it worse, right? But we also did not improve on the situation. And at that point, I'm going to... So I think it's either the ULA now or the Z80. 2 weeks have passed since our last video, so we still have the Speccy from hell, as I call it by now, on the bench. And you'll be happy to learn that we fixed it by now. So let's power it up and show you. Finally got it to work. So very happy that it's finally working again, but was it giving me a hard time? I have to tell you. So it really brought me to my limits. So let me explain a little bit the things that I, misdiagnosed and tried to fix, and how we got it into working condition again. So, but let me power it off because I don't have the heatsink currently installed, so this thing is getting hot quickly. Another thing I want to show you is we have a diagnostic ROMs. So there's an EEPROM built in here as well, so I can, with a switch, switch between EEPROM, firmware ROM and diagnostics ROM, and very great diagnostics ROM you can download from the website Retroleum that also shows you how to install an EEPROM in the Speccy in the first place. So this is a 27C-256, and here's the switch basically, so which allows you to select between original firmware, Speccy ROM and diagnostics ROM. But now let me power it down because I don't want the voltage regulator to overheat without the heatsink. So yeah, how did we get to that state, right? So remember when we adjourned last time, I said, okay, so I really think it's the ULA at that point, nothing else does make sense. So I ordered a replacement ULA, and the only ones you can get, you know, I mean, unless you're very lucky, of course, modern replacements, recreations, the VLA82. And yeah, so I was waiting for that one. I could hear sound basically when the keys were still working from ear and mic, but the internal speaker was dead, so I figured, okay, let's see, and while we are waiting for the ULA, if we can repair the sound in the Speccy. And I went ahead and looked at the schematics again, right, and yeah, so fair enough. So of course the little speaker, I mean, I removed that and looked at it, and the clear plastic membrane that it had was kind of deteriorated, and it was never a great speaker in the first place, right? Very faint even when it was working, so I decided to dodge this and replace it with a more powerful speaker, right? So I got this one here, which is kind of nice, and it has a good bass as well, I can tell you. So, and still, I mean, just replacing the speaker didn't do it, right? Was still not hearing anything. And then, okay, so how does audio work in the Speccy? So that basically the signal is coming directly from the ULA, right? And then it just gets into this, over a diode, into this amplifying transistor, TR7, right? And then it goes into the speaker. And note that this transistor is kind of difficult to replace because this is one of these TX450 transistors, which is an audio low noise amplifier transistor, basically with a very high gain for audio amplifications, for applications like this. And I couldn't find that, so I figured, okay, let's just replace it with a generic transistor. So BC237, right, I didn't have, but I had a 2N 2022, right? This is a standard transistor in the US here. So I put that in, right, and fired it up, and also put in the new speaker, and fair enough, you know, I heard a hum then in the speaker, and then after 10 seconds, what was that? So I had a burning smell, right, and smoke was being emitted from the transistor that I had just put in, right, from TR7, so I figured, oh, did I put that in backwards, right, collector and emitter flipped, but no, it was in there correctly, and so I removed it, right, and then I looked again at the schematics, right, so this is actually a 40 ohms speaker, right, and I replaced this with a 4 ohm speaker, so this was actually drawing way too much current from the little transistor, the speaker. I should have put in a resistor in series with that, so that it would closely match 40 ohms, but yeah. At that point I was thinking, okay, let's just ditch the transistor stuff and instead do a you know, little D-class audio amplifier based amplification of the audio signal. So from Adafruit or Jamesco you can get these little PAM mono amplifier boards for $2 basically, and they are great, right? So they also have a little volume control pod on board here, and then I just routed basically wires from mic into the little PAM audio amplifier board. It needs to be powered with 5 volts, right? And then it goes directly into your speaker. And so I had put the audio in, right? And then finally my replacement VLA arrived, right? And I said, okay, let's plug it in. Now all our keyboard problems will be fixed, right? And I plugged in my new VLA82, fired up the machine, and nothing, right? So I did not get a clear boot. I got random patterns basically, and changing border colors and what have you on the screen. And at that point I was getting concerned, so something that I had put in basically had made the situation worse. And so upon closer inspection I then realized that there was a solder bridge, solder bead that basically fell and shorted out 2 pins on the ROM. So yeah, so never, you know, as a tip, as a hint, never solder with a lot of solder on, you know, an open circuit board like this. Always try to do it on the side. So yeah, with that removed, I mean, I at least got the boot screen, the boot message back, right? And now I was expecting, you know, pushing buttons and the machine would work, keyboard would be fixed because I had the new VLA82 installed. And now, to my absolute horror, basically every key press reset it and rebooted the machine. So none of the keys was now working any longer. And at that point I got suspicious, right? So what else was wrong now? Apparently, you know, also putting stress on the machine with, you know, putting in an extra amplifier and what have you. I thought, okay, let's also replace the voltage regulator, 7805, new one in. No change, of course, right? It runs a bit cooler now, right? And then I looked again at the schematics. So what else could it be? Okay, there's one more transistor here, which is TR6, which is another weird one, ZTX313. And I found a replacement one for this because it's related to the I/O request, basically, right? And the keyboard requires I/O from the CPU and the ULA, so this basically Z80, I think, switches the transistor through here, and then the ULA gets an I/O request, basically a signal, right? So I thought, and this happens for key presses on the keyboard membrane, I thought if this thing kind of is dodgy, I measured it, right? So there are websites online which tell you the voltage levels that you should observe, you know, and so it seems to be a little bit out of range. So I thought, okay, let's just replace it, why not, right? And of course no change, so so it wasn't TR6 either. Then what else could we replace? Since I was already in the process of doing this, I also replaced the 74LS32 and the 74LS00. And the 32 is actually an A advanced low Schottky ALS00. I don't think that's really required, but I put the same thing in again, right? Yeah. So, but I mean, apparently, given that we shorted 2 pins on the ROM, made things much worse, right? Now, none of the keys were working anymore. And I had the same behavior now with my new VLA as well as the old ULA. At that point I said, okay, so it's actually, after all, not ULA related at all, right? So at that point I was down to either the CPU or the ROM, right? Apparently, I mean, the ROM was really the last thing I suspected because I still got a boot message, right? And if you get a boot message, then it says, you know, most of the machine is working fine. And in particular, I think, you know, the ROM would be doing fine then, right? And boy, was I wrong, right? So I socketed the CPU, right? And again, CPU, this is the original one, came out nice and cleanly here. So it's really a PCB of decent quality that if you do it right, you can actually get the chips removed and they're still working, right? So it's still in pristine condition now. And so CPU socket was in, and original CPU, of course, was showing the same behavior. Every key would now, got the boot message, every key would immediately reset the machine. And then I tried to put in some of these spare Z80 CPUs that I have here. I keep a bunch of them for CPC repairs, etc., right? Which is also Z88. And I plugged one of these in, and interestingly then the machine wouldn't even boot to the boot message anymore, right? So it's just I just got a gray border and a black screen and the machine constantly rebooting, right? Not even getting to the boot message. And I've found this curious because that happened with all other replacement CPUs, right? All 5 Z80 CPUs that I tried, none of them could boot the machine. Only the original Z80 from the machine was able to still give me the boot message. And then I was really beginning to suspect, okay, so this is so odd, right? The only thing that's left is actually the ROM, right? And so I removed the ROM, here it is. And this is the region, I think, where I had the solder bridge here, right? And apparently, you know, that must have damaged the ROM. It was already damaged. So because it was resetting the machine for Q to T, but the other keys still worked, right? But yeah, after the solder bridge and my other repairs, I basically pushed it over the edge, and it was completely defect at that point. So on the web you can find instructions on how to replace the ROM with a 27 C512 32 kilobytes EEPROM, right? And this EEPROM here is now large enough to hold the original firmware ROM with a BASIC, as well as the diagnostics ROM, which the same guy here that runs this website created, Retroleum. From there I got the instructions on how to install the EEPROM, as well as the diagnostics ROM, right? So basically you gotta remove, zoom in a bit here, but just check out his websites, great instructions, right? So basically you gotta remove these 2 wire links here, right? And then put in 2 diodes and a 10K resistor and a switch here, which switches the higher and lower 16 kilobyte bit address bit in the EEPROM between VCC 5 volts and ground, right? So you can put a 0 or 1 fixed address for the higher or lower 16 kilobytes on the address of the EEPROM. Yeah, and with that, so did I already show you the EEPROM, the diagnostics ROM? So let's do that again. There it is, right? Very useful, very handy to have. And yeah, now it's yeah, of all the chips, you know, the ROM I would have suspected to be the least likely culprit, right? Because after all, the machine was working to 80%. Huh? Only then when only one CPU would work with this ROM, right? The original one. All other Z80 CPUs wouldn't. And after my solder bridge, basically, between 2 ROM pins, I started to suspect, and the behavior got worse, right? None of the keys were working any longer. I started to suspect that it really must be the ROM of this machine. And yeah, fair enough, bingo. So yeah, that really took us down the rabbit hole, I have to say. So after all, it was the ROM, and if I would have, you know, diagnosed this correctly from the beginning, it would have saved us a lot of work. But now at least I have a very nice VLA 82 replacement, ULA if I should need it. I put on heat sinks here, right? So hopefully my original ULA is still going to last a bit. I also put in now an NEC CPU, which is a CMOS CPU instead of the original NMOS 1 or what that is, right? And so that runs a little bit cooler, but regardless, I put on heat sinks as well, right? And now let's power down the machine again, because I don't want it to break now. And let me put in the heat sink again and put it back together. And finally, our Spectrum from Hell is is fully working and good to go. Really a challenging repair for me, and I would not have thought that a ROM basically with a partial defect would create such a localized error, right? So basically only resetting the machine after a slight warm-up phase, and only for these key presses originally. This is a very highly unlikely ROM defect, right? So apparently the region in the ROM that was handling these keys, right, was defect, and then it was just pulling instructions basically which were invalid, that then caused the Z80 to reset, and only for these keys. How odd, right? So yeah, but I'm glad we sorted that out, and it was a lot of work, but it's a machine worth saving. very iconic, and I really love the Plus with its proper keyboard, and it's still an original Speccy. Alright guys, thanks for watching. Hope this could help you one day to repair your own Speccy. Until then, take care, bye.